All right, I'm back. We are on page 3 of note 6 of Calc AB. We're doing implicit differentiation practice problems. Some of them are going well. Some of them are a little gross, as you can see in part B, which we did not even check. So let's do another one. So this one looks like it'll be not terrible because it's a lot of power rule, but not great because it looks like we're not going to have common denominators. So let's see what we got. So again, I'm skipping that step where I do dx of both sides because it saves a lot of space. You should really do that. So if you're doing these on separate paper, like write that step out. It's good for you. It helps you remember important things, but I'm not doing it. So power rule on the first part, negative 2/3 y to the negative 5/3, but y is a function of x, so this is a chain rule, dy dx. And then 3/2 x to the 1/2. I was definitely going to put negative 1/2 there. You all saw it. So we get this, and then equals, don't forget the derivative of a constant is 0. This is your chance to make the worst mistake, so don't do it. This problem seems way easier than previous problems. Is something wrong with it? I don't know. So I think it's okay. All right, so dy dx is going to be, well, let me, negative 2/3 y to the negative 5/3 dy dx is negative 3/2 x to the 1/2. Moved it over. And then I'm going to multiply by negative 3/2. So I'll get, so I'm doing it a piece at a time in my mind. I'm multiplying by negative 3/2, which clears out the negative 2/3 and gives me 9/4. There's an x to the 1/2. I'm going to divide by y to the negative 5/3, but that moves up as y to the positive 5/3. Y to the 5/3. All right, let's go to the calculator and check that one. That one was quick. So, sometimes when they're quick, I think, oh, something probably went wrong, but I don't know if it did on this one. So the original problem is y to the negative 2/3 plus x to the 3/2 equals 1, x comma y. 9/4 radical x, okay, and then y to the 5/3. We got it. So that one didn't seem as bad, and I guess it actually wasn't. And that's good because you don't want to underthink a problem. You don't want to overthink it. You want to be at exactly the right level of thinking, and it's hard to know where that's happening. Okay, this problem is going to be really, I think, really interesting because there's something going on here. And when we get the answer, I'll show you what I think is going on. All right, so skipping that step. So it's going to be the derivative of sine of something is cosine of that thing times the derivative of that thing. So the derivative of this, super annoying. It's a product, so product rule. First derivative of the second plus second derivative of the first. So where is this coming from? It's the product rule applied to this, right? So this gave us all of this. So that's great. And then equals 0 because we don't want to make that mistake. All right, so now what are we doing? So we have, what do we have here? So either, like this equals 0, right? So either, so there's two ways to do this. I'm going to choose to do it one particular way. I'm going to say that either cosine of x times y equals 0 or x dy dx plus y equals 0. So why am I doing that? I'm basically doing a thing where I have like, if a times b equals 0, a equals 0, or b equals 0. Like I'm basically using that property. And so I have a product. So one thing could equal 0 or the other. Now we're trying to find dy dx. So this first part here has no dy dx in it. So we don't care about it, right? Like, sure, maybe cosine of x times y equals 0. Doesn't help us find dy dx. So instead, we'll deal with the other part. And this part tells me that dy dx is negative y over x. Well, that's pretty interesting because negative y over x I kind of recognize as either the derivative of a circle or the derivative of a hyperbola. I can never really remember. But let's go up here and take a look at this, right? So I'm seeing the sine of x times y is equal to 1. So if I do that, let's see, how to denote this. Down here, the sine of xy equals 1. So if the sine of xy equals 1, I'm going to take the inverse sine of both sides. And it'll be the sine inverse of the sine of xy equals the sine inverse of 1. So the sine inverse of the sine of xy is just xy. The sine inverse of 1 is pi over 2. This actually is a hyperbola, right? You get y equals pi over 2x. And then you could find the derivative from that if you so chose. But that's why the trig functions all disappeared, right? Because this is like a weirdly written hyperbola that didn't need to be written that way, and that's why there's no trig functions in dy dx when you almost certainly were expecting to see trig functions. So that's a weird problem. Let's do it on the Inspire and see what it says. I think it's going to give me I think it'll give me the right answer and then a warning. That's my guess. Be like, I might have done something really weird. Impdiff of sine of x times, not optional, y is equal to 1, x is independent, y is dependent, negative y over x. Not even a warning. Cool. All right. I'm going to do, does it look bad? It doesn't look terrible, so I'm going to do one more in this video. And those are the sorts of words that you come to regret. You know, it doesn't look bad. We have plenty of time in this video. All right, let's see. So first, I'm going to skip this step. I shouldn't do it, but I do. I actually do it all the time. E to the x minus y times the derivative of x minus y with respect to x. Derivative of x with respect to x is 1. Of y with respect to x is dy dx. So 1 minus dy dx equals. What I like about there's not even a product rule in this problem, and that's like awesome because I didn't want to have to do that. You know, it just keeps coming up. Derivative of y squared is going to be 2y, but y is a function of x, so there's a chain rule situation. So dy dx. That's a weird x. Let's try that again. X. Okay, so we got to get everything. I'm going to do the thing. I'm just going to distribute. I'm going to show more work than usual. Because, you know, if you can show the work and not screw up, as opposed to not showing the work and screwing up, like why choose that path in life? Just do the easier thing. All right, everything with a dy dx goes to the left. Everything without goes to the right. So on the right-hand side, I like to start on the right. I don't know why. Negative e to the x minus y. It's fine. I'm going to add 2y dy dx and put it like in the front. So 2y dy dx minus. It's like I kind of sometimes feel like when they like discovered or invented or whatever you want to say, the like factoring and the distributive property, I feel like it was like laziness to just be more efficient in what you write. Like if I had factored dy dx out there, it would have been like just less writing. So dy dx is 4x minus e to the x minus y over 2y minus e to the x minus y. All right, I think that's our answer. I'm going to check it because we're checking everything, so why not? We're checking everything except B. I do not want to check B. I just don't want to type that. Maybe I don't want to find out I'm wrong. I don't think I am, but you know, if I am, maybe I don't want to know. I'm pretty sure that a lot of people will let me know in the comments in the event that I am. It's 2x squared minus y squared, comma x, comma y. So I'm using exp of x minus y. I don't know if I've done that yet in these videos. You should use the template. So over here, there's a template. It's below natural log. I don't know, that's a weird way to describe it. It's on the left-hand column. Use that. It's just faster for me to type exp. And you can see as soon as I hit enter, it's going to change it into e to the, which is what I was kind of expecting. So this, it used all kinds of properties of exponents. So let me type in mine and see how it compares. X minus y. They are, well, why think about it, right? Let's do this. True. So we got it. All right. So that's a thing you can do. You can like type in your thing, see if the calculator says true. You can do like all kinds of anything that you can think of to do that seems like it'd be helpful. You should try to do. That's like a good way to learn a lot of math. All right. So these are the 3 that we did this time. And I will be back in the next video to do the last 2 problems on the page. I don't know if they're any worse than any of these because I don't usually put a lot of thought into that. So I'll be back, we'll do them, and then we will move on. So I will see you then.